Hello there and welcome to the first video that covers Chapter 2 Statistics, Measures of Location and Spread. In the videos we're going to do on this section, we're going to cover 2.1, which is calculate measures of central tendency such as the mean, median and mode. 2.2, calculate measures of location such as percentiles and deciles. 2.3, calculate measures of spread such as range, interquartile range and interpercentile range. 2.4, calculate variance and standard deviation. And 2.5, understand and use coding. Okay, so in terms of 2.1, things that we need to know before we start. A measure of location is a single value which describes a position in a data set. And a measure of central tendency describes the center of the data. Okay. Descriptions of the things that we have looked at before. A mode or the modal class is the value or class that occurs most often. The median is the middle value when we've put the data in some sort of order. And obviously then we've got the mean, which has been calculated using one of two formulas. We tend to write x bar equals sigma x over n. Okay, for discrete data or for continuous data, we're going to be looking at x bar equals sigma fx over sigma f. Okay, so we're going to be utilizing these formulas quite a little bit within this topic. Okay, so one of the things we might want to look at to start with is making sure that we pick the correct average. So there are advantages and disadvantages to each of them that we can just have a quick look at. So if we're using the mode, an advantage of the mode might be that we can use the mode when the data is qualitative or quantitative and where we have one or more modes. So certainly we can have something that is bimodal, okay, which may be an advantage in terms of being able to describe the data. A disadvantage, okay, is it's not very informative if each of the pieces of data only occurs once, okay? In terms of median, this is best used where there are extreme values because obviously it won't have an effect on the overall answer if we're taking the middle value once we've ordered it, okay? But it is less representative as it does not depend on all the items of data. So that would be a disadvantage for your median. And then for your mean, an advantage might be it uses all of the pieces of the data. But as we've just said, with an advantage for the median, a disadvantage for the mean might be that it can be affected by extreme values. Okay. So we've just had a look at the mean notation. Okay, as just remind you, if we're looking at a list of data, we're going to use sigma x over n. If we're using a table of continuous data, we're going to be looking at sigma fx over sigma f. Okay, and obviously, if it's a group frequency table, x in this case is going to be the midpoint of the groups. And we'll talk about a little bit about how we make sure we find the right midpoint, because it might vary just a little bit from the work you've done previously at GCSE. Okay. So let's have a look at a straightforward example to get started then, everybody. Okay. So in this case, Rx is the number of petals. Okay. And we're going to need to find f of x. So we're going to need a little bit of working out at the end of this to be able to do that. Okay, and we're going to need the total for our frequency, and we're going to need our total for our f of x in order to be able to find the mean for part B of this question. Okay, so if we do a little bit of multiplication, we're going to get 40. We're going to get 342. We're going to get 203, 24, and 18, and they total 627. Okay, our frequency for this one add up to 99. Okay, just going to rub that out down there. That's it. Okay, so in terms of the modal number of petals, we just need to identify where the frequency is highest and read left. So our mode in this case is going to be 6. Okay, for our mean then, we're going to use E of fx over E of f, which is going to be 627 divided by 99, which in this case is going to be 6.3 recurring. And obviously, we'd need to look at the question in terms of what we need to round our answer to as we go along. Okay, so that's a fairly straightforward example. Let's have a look at one where it's a little bit more difficult in terms of what we need to do. So we've got a table for this one. Okay, and we've got time rounded to the nearest minute. Okay, so we do need to work out a few little bits and bats. Okay, we're going to need to do a midpoint. So I'm going to put my midpoints just in there. I'm going to put my midpoints just in the middle there. And I'm going to do my fx there. But we do need to talk, everybody, about what the class width are. So any data that you get in a table is continuous data. So essentially, there are no gaps between the groups. So even though the first group says 5 to 9, there'll be a point where that group changes to the group 10 to 14. So we do need to consider that when we're looking at our midpoints. So in this case, this first group would actually go from 4.5 to 9.5. Okay, so in terms of that, the midpoint will be 7. Okay. The next group will go from 9.5 to 14.5. Okay, so our midpoint for that group will be 12. Okay, so if we just keep considering as we go down and have a look at it, if it's most of the questions that we're going to do will work this way. There will be a few little examples that are slightly different, which we're going to look at as we go through the video. So let's fill in the rest of the midpoints. 17, 22, 27, and 32. And now we've got the midpoints, which is our x value, and our number of conversations is our f value. We can work out our fx column: 14, 108, 340, 286, 216, and 96. Okay, we're going to need a total for that one. We're going to need a total for that one. So our total is going to be 55 there. Our total here is going to be 1060. So our estimate of the mean which, if you remember, is our sigma fx divided by our sigma f, is going to be 1060 divided by 55 in this case, which gives us an answer 19.3. Okay, which would be obviously 19 minutes if it asked you to put it to the nearest minute. Okay, so that's an example of one where the groups are fairly straightforward. We're going to have a look at one that is almost a little bit of a special case that you do need to remember next. Okay, so here's our next one. And if you have a look at the little bit it says here in the little pink box, it says that age is always rounded down. Okay, so if you think about it, for that first group from 0 to 5, we can't go to negative 0.5 at the start because 0 is the youngest that somebody could be technically. But if you think about it, you are still 5 years old right up to the day before your 6th birthday. So we can't use 5.5 in this case. We're going to have to be a little bit more careful about how we look at the groups. Okay, so the actual end boundary for each of the groups is actually the age that starts the next group. So for this first group, we essentially need to be looking at 0 to 6. Okay, for the next group, it's going to be 6 to 11. Okay, 11 to 21 and so on. Okay, so you just need to be really careful, especially if you see it's an age question. Okay, So with that in mind, that gives us midpoints of 3 for the first group. Okay, it gives us 8.5 for the second group. It gives us 16 for the third group, and working our way down, the next group will be 21 to 41, so that gives us 31 for that group, and the final group will be 41 to 71, which gives us 56 for that group. Okay, I'm just going to fill my frequencies in. Okay, that's 120. Okay, we can work out our FX now for these. So we've got 42, we've got 136, we've got 176, we've got 1,457, and we've got 1,792. Okay, so just be really, really careful. It's absolutely imperative here that we do pick the right midpoints, thinking about what the first class is discussing. Okay, this comes to 3,603. Okay, so our estimate of the mean, and remember it's an estimate of the mean because this is group data, so we don't actually know the exact values. So it's the E of fx divided by the E of f, which in this case is 3,603 divided by 120, which is going to give us 30.025 or 30 years rounded to the nearest whole number. Okay, so we've had an example there using time. That's reasonably straightforward, but we've had one with age that we just need to be a lot more careful on in terms of how we do it. Okay, the last little bit on this video then is the last little part of 2.1, which is a combined mean question. Okay, so we're given the data, we're given there's 32 students, 20 boys and 12 girls, and we've got a mean for the boys of 76% and a mean for the girls of 82%, and we've got to work out the overall class mean. Okay, so if we think about it, we can work out that we can take essentially that the 20 boys have all got a score of 76. That's how we're going to look at it because that's the mean. Okay, and we're going to say the 12 girls all got a score of 82 because that's the mean for their class. And then we know how many students there are in total. So there are 20 students, boys, there are 12 girls, which gives us a total of 32. So we can pop our working out down like this for this one. Okay, and this is how we can manage to combine them. So let's have a look at the next little bit. If we work that out a little bit, we get 2,504 divided by 32, which says then that our mean for the entire class will be 78.25%. Okay, so this is a way that we can find a complete value if we're given two different sets. So we've done it for the boys, we've worked out the girls, and then we've obviously taken a total for the entire class. So these are the examples, everybody, that cover 2.1 from the chapter. We are going to move on in the next video and have a look at other measures of location, which will cover 2.2.